Hi, um, my name is Dennis Varghese, and I work at Vaisala X Weather. I'm the product owner, and today my topic is covering about the impact-based forecast for the energy sector. I've been working at Vaisala for just over a year, and I'm excited to talk on this topic. So, approximately 7 months ago, we launched the Vaisala X Weather. So, hu- humanity has been facing challenges throughout the existence of our history: war, diseases, and hunger. And we all know that we have a new one, that is climate change. There is one thing that is different with the climate change than with the others. It's the fact that we can measure it now. So, we can measure it and we can quantify it. And to and to anyone who's building a product, we know that solving a problem starts by being able to measure and quantify. At Vaisala X Weather, we are the world's best at measuring and understanding the weather and environment. The value of making accurate weather observations is way beyond making good weather forecast. It is actually to make decisions and act in response to weather and climate change. If you really want to have truly accurate weather forecast where you stand or where your business assets or where your customers stand, you have to measure weather and enhance weather forecast in the local environment. Here at X Weather, we have the tools and technologies that help us monitor and forecast for things like air quality, renewable energy production, severe weather, heat waves, which is unfortunately more in the news these days. With X Weather, we have the data as a service and solutions as a service, i.e., DaaS and SaaS, that really help us solve these challenges for any locations on the globe. So let's step back before we go into the slide. And I'm looking at trying to step back and see like where we want to start from. So weather forecasts has become an indispensable part of our daily routines. They're easily accessible and are widely used by people from all walks of life. Thanks to the availability of smartphones and internet connectivity, we have now the convenience to access weather forecasts at our fingertips. So, this really empowers us with valuable information and enables us to make informed decisions. So, weather forecast plays a crucial role in a lot of aspects of our life. Whether we are planning our outdoor activities, scheduling events, or simply even deciding what to wear, which is sometimes really important where when we live in the Nordics, especially in Finland, weather forecasts serve as reliable guides. They provide us insights into what are the conditions that we are expecting, so that we can prepare and we can optimize how we choose to wear and how our experiences need to be. We rely on these forecasts to determine whether we should even bring an umbrella or wear sunscreen or dress in layers. It's also not uncommon to hear jokes about occasionally how unpredictable weather forecast has become, and there are occasional inaccuracies. They have also come with stories about how we adapt to sudden changes. These stories highlight, okay, the weather has been wrong, the forecast has been wrong, but these stories also cover how we have adapted to this change and how we have embraced and being flexible even when the forecasts are not very accurate. But however, it's not just enough, no longer sufficient, that we solely rely on knowing what the weather forecast is for tomorrow, for the day after, or even for the coming week. um, it's important that we understand that the intensity of these weather or climates, they are increasingly affecting the climate change. And we understand that sometimes these climate change have a big threat through high winds, ice storms, lightning strikes, and they really affect how we want to prepare when we actually want to spend the time in the weekends and we know that we are having a severe weather. As a society, we want to strive and better comprehend these consequences of the weather, and and this is where we want to understand the risks of it. So it's always important that we want to transition away from knowing just what the weather is, but to better understand what the impacts of these weather are, and this impact is sometimes crucial to really help in the decision making. So what I was thinking about this slide was that sometimes in terms of decision making, we are faced with when we are faced with the threat of severe weather, we normally rely to our cities or governments to really communicate us very clearly what the impact is, what the severity is. And sometimes it's important that, and that is really important for you as humans to decide like what decisions we take to mitigate the risk. So when it comes to impacts of weather as to people, what I wanted to really communicate what was it's the next paradigm of the weather, that we really understand that it's not just knowing what the weather is tomorrow, but also we understand that what decisions we take from there. And sometimes clear communication of the decisions and the impact is essential. So, in a nutshell, what I wanted to really put kind of across is that when it comes to the weather of tomorrow, we are at X Weather really focusing on delivering impactful weather, and not just of saying that you are at a risk at a weather event, but also giving you tools that would help you decide what what steps you would need to take. And I wanted to bring this in the context of an energy sector, which is something which is truly under the midst of change in the weather and the climate change. So, with this slide, what I actually wanted to show, I wanted to actually capture a kind of a high level view of how the energy landscape is currently at, say in the Nordics region. And and why I wanted to show here is that we as humans, we rely on our energy providers for our heat to our homes, for the power. And it's also very interesting to see what's the landscape of now. It has been that it has become highly decentralized. So there are three things that you want to see over here that I want to point out. Is you have the generation of the power, you have the transmission of the power, and you have consumption of the power. And this is weather is a very impactful for the energy sector, because weather conditions have a profound impact on the operations, especially in the production and the distribution of power. So in this landscape, which is completely what I wanted to convey, is a decentralized kind of energy network. Energy is generated from a variety of sources, far away from where it's consumed, and also sometimes close to where it's consumed. These energies include renewable energy sources like solar power, wind turbines. They include hydroelectric power plants, you have biomass, you have gas turbine, and they all generate energy for the network. And it's crucial that when you have all these energies dependent on the weather being, you have certain patterns in the human behavior that based on the weather the consumptions will increase. It's very important that we are able to understand and manage the network so that we can keep the supply and demand in balance. We also want to ensure that when we transmit the power is arrived and reached, and there is no loss of power. And sometimes all this power that is created, there is no waste. So what we're aiming for here is that even the energy sector really want to have the lean and the efficient approach in operating all these pieces in the landscape. Because in this current world, an energy company all operate in generation, in transmission, and even provide solutions even in the consumption. So it's very so the energy sector really has uh, a decentralized approach, a network out, and they have a more dependency on weather. So take for example the CHP, wherein combined heat and power plant. So a combined heat and power plant is one that actually delivers heat to via district heating to much of the Nordics, and it's also seen in few countries in the Europe. So here, weather plays a very weather plays a very important role. The weather outside that the environment faces plays a very important role for the power plant to really understand how much heat needs to be produced. And here, it's not about how much heat needs to be produced; it's about the precision in which they can produce the heat just enough so that they rely on lesser greenhouse gas emissions, and they build the right amount of heat so that there's no heat wasted. And this affects their bottom line, and also this also plays a very important role in the targets that they have set in being net zero. Now over to the wind parks. Here, wind parks have grown in prominence in much of the Nordics, and it's the cheapest source of energy that we have right now. These wind parks are sometimes on land, they are offshore, and they're very remote locations. So much of these wind parks are remotely managed, and it's very important to see that they operate and they produce wind energy, and they get paid for the amount of energy that they paid so that they remain profitable. So operation wise, the wind turbines blades are susceptible to icing formation, which sometimes might even affect how they operate and even their bottom line. So I really want to kind of pick on two of these things and talk about like how weather plays a very important role for that. And this is truly important to understand. So here I have something that really wants to deliver that information that the energy sector depends on weather, and here I want to make it simple in terms of temperature. So what I have over here is a graph of how we have uh, the the usage of water, hot water, especially say in a district heating, and how we know that there is patterns of temperature, that when the temperatures drop, that's when the heating requirements increase. So we have months when the temperatures are very low, the amount of heat that needs to be made is higher. So we know that in that sense there is a pattern that we follow, and this pattern is very cyclical, that we have the winters, we have more heat to be generated. Also, we know that sometimes, with respect to certain days in the week, there are certain patterns. Like in a specific day, in the mornings, there is more energy requirements, especially in the early morning because we go to work. And especially on the weekends, we are at home, the patterns are different. So, there is a lot of human behavior involved here that is very cyclical, that can be really be modeled, and there very little change. So here, what I want to say here is that when we talk about temperature, it plays a very important role in really understanding the energy demand. And I want to really kind of make a simplified view of how it looks with respect to a district heating. So if you look at district heating, the main role of a district heating company or a combined heat and power plant is to produce and secure the heat demand of the people and the business. And we're talking about people as in homes and in offices. So here, what they have is they have the heat plants that is running on natural gas, oil, or electricity. And you have the combined heat and power plant, which I showed in the previous landscape, are dependent on renewable energy. So, what we really want to understand here is that these heat plants that are running on natural gas, oil, or electricity are generally the backup heat plants that gets fired up when the actual demand is not met. So, when it comes to really understanding how do we understand how much heat demand needs to be made, we come with prediction here. So, the constant factor of the prediction is a human behavior, which I showed previously. And here, the variable of this human prediction is the weather forecast. because the temperature and the weather being so different for different places and they change often. They This is where the weather change down to 1 degree centigrade means a certain amount of heat that needs to be generated. So that means if the heat is not generated enough, then they have to rely on the heat plants that is based on carbon energy sources to generate the heat. And and this is needed because they want to ensure that they optimize the production, and this optimization is important that they be cost efficient. And also, when they make excess amount of energy, they trade the energy or the heat, so and the heat is transferred to other plants. So this is kind of like the bottom line of a combined heat and power plant company, where they want to deliver heat for the people and the business, but they also want to be operationally efficient. So here, this is the important aspect that I wanted to say, that for the energy sector, weather plays an important role, and even the amount of heat that needs to be kind of heat production that needs to be made is also based on the weather. So putting a timeline of how this is actually captured, what I wanted to share here in this slide here is that when you talk about forecasts that they depend on weather, what we have in the bottom are different impacts on their operations that they do every day. And for all these things that they do on a daily point, they rely on forecasts at a different timeline. So that means you have certain weather forecasts they would depend on, that is at a 15 to 30 minutes that is needed so that they can actually do a certain action. And then there are certain timelines that they need to have certain specific forecasts that is needed to really complete and start or stop those power plants when they have not met with the actual demand. So here, for an energy sector, weather forecast and accurate weather forecast delivers not just the what is the weather outside. What we need to think about is what is the impact that this delivers, and exactly that is impact that they would do that would affect their bottom line. So the key challenges that the energy sectors face, just to summarize, is that they are completely decentralized. So they have to ensure that they coordinate multiple energy sources and ensure that the flow of energy is efficient. Also, the weather fluctuations normally affect a lot of the availability of the renewable energy sources. So we're talking about the wind, we're talking about solar. They're dependent on weather. So you need to understand and forecast them so that you can efficiently make them available then and there. Because what we need is that we need to have optimal weather pricing and weather availability, so that that is predictable, and that delivers value to the production, to the producers of the energy, and also to the consumers. And also, we also want to rely and we want to avoid relying on carbon sources. Also, when we talk about connecting different power sources to the people, connecting them through grid is something very important, because these grids are very remote and they are normally exposed to severe weather like snow, like thunder strikes. So the operations of the running a business also involves how efficient you are in really being alerted and being mitigating the risks of how you would operate and what decisions you take when you face with the severe weather. So this is what normally comes with decision making, understanding what the next steps are. And this is the next paradigm on the weather part, that currently we know as consumers of weather is just looking at weather as what's the temperature out now. So as a solution that we are right now is that we have this product called WX Beacon, and this product is meant to understand the impacts on the energy sector. So this product delivers 36% more accurate weather forecast. And this is a software as a solution, where we have hardware intelligence sensors bundled. And here, what we are really after easy access to the impact based forecast as subscription. It's a complete turnkey solution. So in this turnkey solution, what we believe is that when you want to have access to the actual accurate forecast, that's truly possible when you have measurements measuring it, so that we can rightly quantify and solve those impact solutions. So what we do is we deploy sensors as a turnkey solution to the areas that matter to the business, and these are remote places where weather forecasts are generally very inaccurate. And then we deliver hyper local forecast to the businesses that they want to have accurate weather. So we're talking about temperature, we're talking about wind forecast, and these are very much uh, important direct parameters for energy sectors. Also, we deliver access to via the api and the ui, and this is where we have the option of an energy sector having the data directly into their systems via the API, and we have the decision makers having the UI to take decisions based on what we deliver as impact on the UI. So our product is having an API, and this is basically a schema of how the API is actually priced, and this is what the API is. And we have a docs page. We have a landing page for accessing the API, and this is what our product is. And just want to say one more point that is important is that the devices that basically deliver their sensors, and these sensors are very reliable. Actually, most of two of these sensors are actually part of the Mars Perseverance rover that's actually in Mars, and we have actually used the same sensors, but we have productized it for the actual on Earth solutions. But these sensor versions are in the Mars rover. So I hope you have kind of believed in the story, and if you have any questions, please reach out. Thank you.